Hello, dear listener, and welcome. As you settle down tonight, perhaps lying comfortably, allowing your breath to deepen and slow, let your thoughts drift gently, beyond the confines of your room, beyond your home, your city, your planet, to the most expansive, profound concept imaginable, the universe itself. Imagine, for a moment, everything. Not just the ground beneath you, the air you breathe, the stars you might sometimes glimpse in the night sky, but all of space, all of time, and every single thing contained within that boundless expanse. This, in its most fundamental essence, is the universe. It is a concept that stretches the very fabric of our understanding, a silent, cosmic symphony playing out across eons. The scientific definition paints a picture of astonishing breadth. The universe is all of space and time, a unified concept we call space-time, and every single one of its contents. This means every whisper of energy in its countless forms, from the gentle hum of electromagnetic radiation to the vibrant dance of matter. It encompasses the majestic planets, the serene moons, the blazing stars, the magnificent galaxies, and even the vast, quiet emptiness of intergalactic space. But it's more than just matter and energy. It also includes the very physical laws that govern them. Think of the unseen elegance of conservation laws, the predictable ballet of classical mechanics, or the mind-bending principles of relativity. These are the fundamental rules that orchestrate the cosmic dance. Yet, this definition, while scientifically precise, only scratches the surface of what the universe truly embodies. Philosophically, it is often seen as the totality of existence. Consider that for a moment: everything that exists, everything that has ever existed, and everything that ever will exist. It's a profound thought that invites us to ponder the very nature of reality. Some thinkers even suggest that this totality should include abstract concepts, the elegant certainty of mathematics, the guiding structures of logic, the very ideas that shape our perception and understanding. When we speak of the universe in this sense, we are truly speaking of the cosmos, the world in its entirety, nature in its most raw and magnificent form. It's a concept that transcends mere physicality and invites us into a realm of pure, unadulterated wonder. The very word universe carries with it a history, a lineage of meaning. It journeys to us from the Old French universe, which itself gently unfurls from the Latin universus. And what did universus mean? It meant combined into one. A beautiful image, isn't it? All these disparate elements, all this vastness, all this incredible diversity, somehow, inextricably, woven together, combined into one singular, magnificent whole. Ancient Roman philosophers like Cicero used this term, sensing, perhaps, the same boundless unity that we contemplate today. The ancient Greeks, those profound thinkers, also grappled with this concept, bestowing upon it names that echo with their deep philosophical inquiries. They called it Pan, which translates to the all, a simple yet powerful declaration of its comprehensive nature, encompassing all matter and all space. They also spoke of Holon, meaning all things, though some interpretations suggest this didn't necessarily include the void, the emptiness between things. And, of course, they had Cosmos, a term that resonates deeply even now, meaning the world, the cosmos, a word that implies order, beauty, and harmony in the grand design. These ancient words, like quiet echoes across time, remind us that humanity has always gazed upwards, seeking to understand the entirety of existence. Even in modern languages, we find these echoes: the German Das All, Weltall, and Natur, or in English, terms like everything, as in the elusive theory of everything, or the cosmos, as in the study of cosmology, or the world evoken. Concepts like the intriguing many worlds interpretation, or simply nature, reminding us of natural laws and natural philosophy. Each word, a gentle invitation to contemplate the infinite. Now let us turn our gaze to the story of this universe, its grand chronology, its epic beginning. The prevailing model, a testament to decades of scientific inquiry and observation, is the Big Bang Theory. Close your eyes for a moment, and try to imagine a time, some 13.787 billion years ago, with a tiny margin of error of just 0.020 billion years. This wasn't merely a point in space, but the very beginning of space and time themselves. The Big Bang model suggests that the earliest state of our universe was an extraordinarily hot and incredibly dense singularity. It's not an explosion into space, but rather an expansion of space itself. Picture this, an unimaginable primordial energy, concentrated beyond anything we can truly conceive, a cosmic fire, not burning in the destructive sense, but radiating with the very essence of creation. From this incredibly hot, dense crucible, the universe began its magnificent journey of expansion. Imagine a balloon being slowly, gently inflated, every point on its surface moving further away from every other point. That's a simplified, two-dimensional analogy for the stretching of space. As the universe expanded, it also cooled. Think of a vast, cosmic breath exhaling into the emptiness. This cooling was gradual, allowing for profound transformations. In the immediate aftermath of the Big Bang, the universe was a chaotic soup of fundamental particles, too energetic to coalesce. But as the temperature dropped, the conditions became just right for the first subatomic particles to form, quarks and leptons, the building blocks of matter. Then, with further cooling, these quarks could combine to form protons and neutrons. And eventually, after about 380,000 years, a mere blink in cosmic time, the universe had cooled enough for the simplest atoms to form, hydrogen and helium. Imagine this nascent universe, filled with vast, glowing clouds of these first, fundamental elements, drifting, slowly, majestically. These giant clouds of hydrogen and helium weren't perfectly uniform. There were tiny ripples, infinitesimal variations in density, like subtle currents in an otherwise calm cosmic sea. Over immense stretches of time, the invisible, persistent hand of gravity began to work its magic. It drew these atoms, these clouds, towards the places where matter was ever so slightly more concentrated. Picture a cosmic dance, a slow, elegant waltz where particles are drawn together by an unseen force, spiraling inwards, condensing, growing denser. And what did this slow, gravitational gathering create? It created the first galaxies. Immense, majestic islands of stars, born from those primordial gas clouds. Within these early galaxies, the gas continued to collapse, forming denser pockets that ignited under their own gravitational pressure, giving birth to the first stars. These weren't just any stars. These were the cosmic pioneers, the first celestial furnaces, forging heavier elements in their cores, scattering them into space upon their magnificent deaths. And from these stellar nurseries, from this cosmic dust and gas, from these recycled elements, eventually, everything we see today was born. New stars, intricate nebulae, wondrous planets, and even, ultimately, the very atoms that compose you and me. It's a story of profound interconnectedness, a cosmic lineage that traces back to that singular, luminous beginning. For a long time, humanity's view of the universe was quite constrained, reflecting our limited perspective. Early cosmological models were geocentric, placing our Earth, quite naturally, at the very center of everything. Imagine, for centuries, believing that every celestial body, every star, every planet, revolved around our humble home. It was a comforting, if ultimately incorrect, no. Tie-in. But then came the European scientific revolution, a period of profound awakening, where careful observation and meticulous reasoning began to peel back the layers of misconception. Astronomical observations, driven by pioneers like Copernicus, Galileo, and Kepler, led to a revolutionary shift: the heliocentric model. The Sun, not the Earth, was at the center of our solar system. This was a profound act of humility, a step towards understanding our true place. But the journey of discovery didn't stop there. Further observational improvements, through ever more powerful telescopes, revealed an even grander scale. We realized that our Sun, which once seemed so central and immense, is merely one of hundreds of billions of stars, countless glittering jewels, all bound together in a vast, spiraling collection we call the Milky Way galaxy. And then, the universe truly began to unfurl its breathtaking scope. The Milky Way, it turned out, was not alone. It is but one of hundreds of billions of galaxies scattered across the observable universe. Imagine that for a moment, not just billions of stars, but billions of galaxies, each containing billions of stars. It's a scale that defies easy comprehension, a tapestry of light woven across unimaginable distances. And within these galaxies, we've discovered, many of these stars are not solitary. They are accompanied by their own retinues of planets, worlds orbiting distant suns, some potentially harboring conditions for life. As we zoom out further, observing the universe at its largest scales, an astonishing pattern emerges. Galaxies are not haphazardly strewn about. On the grandest scales, they are distributed remarkably uniformly, and the arrangement appears the same in all directions. This profound uniformity implies something truly remarkable. The universe, on these vast scales, has neither an edge nor a center. It's a concept that liberates us from the anthropocentric notion of a single focal point, suggesting an infinite, boundless expanse where every point could, in a sense, be considered a center. However, when we zoom back in slightly, to smaller, more intimate scales of cosmic structure, we see a different kind of artistry. Galaxies are not merely uniform. They are gathered into clusters and superclusters, immense gravitational congregations of hundreds or even thousands of galaxies. And these clusters and superclusters, in turn, form an even grander, more intricate architecture, immense filaments that stretch across cosmic voids, creating a vast, breathtaking foam-like structure. Imagine a delicate, luminous web, where the threads are made of galaxies and clusters, and the spaces between them are vast, empty regions where matter is sparse. It's a cosmic lacework, a delicate filigree of gravity and matter, sculpted over billions of years. The early 20th century, a period of immense scientific upheaval and revelation, truly solidified our understanding, bringing forth the Big Bang theory. It painted a picture of a hot fireball, a primordial furnace that was continuously cooling and becoming less dense as the universe relentlessly expanded. This gradual cooling, this gentle exhalation, was crucial. It allowed the first subatomic particles to form, then simple atoms, primarily hydrogen and helium. And from these humble beginnings, this initial cosmic mist, the universe began to weave its intricate structures. Giant clouds of hydrogen and helium, under the subtle but relentless pull of gravity, were gradually drawn towards the places where matter was ever so slightly denser. These concentrations slowly, majestically, condensed over eons, giving birth to the first galaxies, the first stars, and ultimately, everything else we observe today. It's a story of simplicity evolving into profound complexity, a testament to the power of fundamental physical laws unfolding over vast stretches of time. But our journey into the universe's composition holds an even deeper mystery, a profound revelation that challenges our everyday perception of reality. By meticulously studying the subtle yet powerful effects of gravity on both matter and light across the cosmos, scientists have uncovered an astonishing truth. The universe contains far far more matter than is accounted for by all the visible objects we can detect. Think about it. The stars that twinkle, the galaxies that spiral, the luminous nebulae, the vast clouds of interstellar gas, all these brilliant displays of cosmic fireworks represent only a tiny fraction of the universe's total mass. This unseen matter, this silent majority, is what we have come to call dark matter. It is a profound enigma, a substance that does not emit, absorb, or reflect light, rendering it invisible to our telescopes. Yet, its gravitational presence is undeniable, shaping the structure of galaxies, influencing their rotation, and acting as the invisible scaffolding upon which the cosmic web is built. Imagine a hidden river, its currents unseen, yet its powerful flow guiding the boats upon its surface. Dark matter plays a similar role, a silent, pervasive force shaping the very architecture of the cosmos. In the widely accepted lambda-CDM cosmological model, a sophisticated framework that attempts to describe the universe's evolution and composition, dark matter accounts for a staggering proportion of the universe's mass and energy, approximately 25.8%, with a margin of error of 1.1%. But the story doesn't end there. There's an even more mysterious, more dominant component. About 69.2%, with a margin of error of 1.2%, of the universe is composed of something even more elusive, dark energy. This is perhaps the most enigmatic force in the cosmos, a mysterious form of energy that is believed to be responsible for the observed acceleration of the universe's expansion. Remember how we spoke of the universe expanding since the Big Bang? For a long time, it was thought that gravity would eventually slow this expansion down, perhaps even reverse it. But observations have shown that the expansion is actually speeding up, as if some unseen force is gently, yet relentlessly, pushing everything apart. Dark energy is this mysterious agent, a cosmic anti-gravity, stretching the very fabric of space-time at an ever-increasing rate. Imagine a silent, pervasive pressure permeating all of space, pushing the galaxies further and further away from each other, gently accelerating the cosmic dance towards an unknown future. So, when we look at the ordinary matter, the baryonic matter, the stuff that makes up stars, planets, gas clouds, and indeed ourselves, it constitutes a surprisingly small fraction, only about 4.84%, with a margin of error of 0.1% of the universe's total mass and energy. And even within that small percentage, the visible objects, the stars, planets, and luminous gas clouds, only form about 6% of this ordinary matter. This means that almost 95% of our universe is made up of things we cannot see, things we do not fully understand, dark matter and dark energy. It's a humbling thought, a reminder of how much remains veiled, how much mystery lies at the very heart of existence. It invites us to embrace the unknown with a sense of wonder, recognizing that our visible reality is but a small, shimmering island in a vast, unseen ocean. We know that the portion of the universe that our instruments can currently detect, the observable universe, spans an approximate diameter of 93 billion light-years. To truly grasp that scale, consider that a light-year is the distance light travels in 1 year, a distance so immense that it's almost impossible for our minds to fully process. 93 billion of those vast stretches. It is a staggering expanse, filled with countless galaxies, each a universe in itself. Yet, here's another profound thought: the total size of the universe, beyond what we can observe, is not known. It could be vastly larger, perhaps infinite. Our observable universe is simply the region from which light has had enough time to reach us since the Big Bang. Beyond that cosmic horizon lies a realm we cannot yet glimpse, a silent expanse waiting to be discovered, or perhaps forever beyond our reach. This leads us to the grand questions, the profound philosophical inquiries about the ultimate nature and fate of this magnificent cosmos. There are many competing hypotheses about the ultimate destiny of the universe. Will it continue to expand indefinitely, eventually cooling to a state of ultimate emptiness and cold, a big freeze? Or will the accelerating expansion caused by dark energy tear everything apart, even atoms themselves, in a big rip? Could the expansion eventually stop, and reverse, leading to a big crunch, collapsing back into a hot, dense state similar to its beginning? These are not just scientific questions, they are existential ones, prompting us to consider the impermanence of all things, even the universe itself. And what, if anything, preceded the Big Bang? This question stretches the limits of our understanding, touching upon the very boundary of causality and existence. Some physicists and philosophers, in a gesture of profound intellectual humility, refuse to speculate. They doubt that information about prior states will ever be accessible, suggesting that the Big Bang represents not just the beginning of our universe, but the beginning of time itself. How can something precede time? It's a concept that forces us to reevaluate our fundamental assumptions about linear progression and cause and effect. Yet, other physicists, in their boundless curiosity, have ventured into even more speculative and mind-bending realms. They have suggested various multiverse hypotheses, proposing that our universe might be just one among many, an infinite tapestry of universes, each with its own laws, its own history, its own unique unfolding. Imagine our entire cosmic story, with its billions of galaxies, its dark matter and dark energy, its very laws of physics, might be but a single bubble in a vast, frothing ocean of other universes. Perhaps these multiverses are born from quantum fluctuations, or from different outcomes of cosmic inflation, or perhaps they exist in different dimensions, subtly overlapping with our own. It's a concept that opens up breathtaking possibilities, challenging our perception of uniqueness and singularity, inviting us to contemplate an even grander, more incomprehensible reality. As you lie there, perhaps drifting closer to sleep, consider the profound implications of these ideas. The universe, in its very essence, is a narrative of unfolding mystery. It is a story that began with an unimaginable burst of energy and has continued for billions of years, creating stars, galaxies, and eventually, life that can contemplate its own origins. It is a universe dominated by the unseen, by forces and substances that defy our immediate senses, reminding us that reality is far richer and stranger than we often assume. The journey of understanding the universe is a journey of continuous humility and wonder. From ancient Earth-centered views to our current understanding of a vast, expanding, and largely mysterious cosmos, humanity has repeatedly been asked to let go of its assumptions and embrace a grander, more intricate reality. There is no edge, no center, at least not in the way we typically conceive of them. We are part of a colossal, interconnected whole, where the forces that govern the smallest particles are the same forces that sculpt the largest galactic filaments. As you breathe deeply, imagine the immense scale, the silent expansion, the gentle, gravitational dance of billions of galaxies. Feel your connection to this vastness. The atoms that make up your body were forged in the hearts of stars that lived and died billions of years ago. You carry within you the stardust of the cosmos, a living, breathing connection to that fiery, dense bag. Inning. Let the sheer scale, the profound mysteries of dark matter and dark energy, the possibility of countless other universes, gently wash over you. There is a deep, abiding peace in recognizing our place within this grand cosmic narrative. We are small, yes, but we are also participants, observers, and contemplators of something truly magnificent. Allow these thoughts to settle, not as intellectual burdens, but as whispers of wonder. The universe continues its silent, relentless journey, expanding, evolving, forever holding secrets. And in that vast, unfolding mystery, there is a serene beauty, a quietude that can lull the mind. Rest now, knowing that you are a part of this incredible, expanding story. The stars, the galaxies, the dark energy, the mysteries yet to be uncovered, they are all part of everything. And so are you. Good night, dear listener. May your dreams be as vast and peaceful as the cosmos itself.